Hello friend, hello dear student, hello dear, how are you? I hope you all will be fine. I'm also fine, thank you. Today is lecture number 14 of crystal field theory CFT. Today lecture number 14 of crystal field theory. And today lecture what will we study? And today lecture we will be study in detail Jahn-Taylor distortion. We will study Jahn-Taylor distortion with details. Okay, first of all, what is Jahn-Taylor distortion? Jahn-Taylor distortion is the distortion of geometrical. It is the distortion of a non-linear molecular system that reduces its symmetry and energy. This distortion, how can we define? First of all, I am writing definition because when I was a student, I have also the problems with definition, so you can have proper definition. We can define Jahn-Taylor distortion. It is a geometrical distortion of a non-linear molecular system. Non-linear molecular system that reduces its symmetry and energy. Due to Jahn-Taylor distortion, the symmetry and energy of the system is decreases. When and also we know that when the system that have low energy, it will have higher stability. Reduce symmetry and energy means to get stability. To get stability, the system or the complex. To get stability, the complex. This distortion is typically observed among only octahedral complexes where the two axial bonds can be shorter or longer than those of equatorial bonds. In this complex, it will be observed in octahedral complex. Octahedral complexes where two axial bonded are shorter or longer than those of the equatorial bond. As in previous lecture, I already told you that how the bonded are become shorter or longer. So is it right? Okay. The second question is that why Jahn-Taylor distortion occur? What is the reason? First reason is that that reduces symmetry and energy, or you can say that Jahn-Taylor distortion that at any non-linear molecule with a special degenerate electron ground state. Here, a degenerate electronic ground state will undergo a geometrical distortion that removes the degeneracy because the distortion lower the overall energy of the system. At lower overall energy of the system. Is it clear? As theta system, you can also write the complexes. Okay, that's the definition. So let's proceed forward. You can take screenshot from this position. Now I'm just clearing the board because to proceed the lecture. So how Jahn-Taylor distortion occur? Let's suppose Jahn-Taylor distortion is basically show that how show Jahn-Taylor distortion is due to the electron position in the d orbital or in the dx ion. So how, if there are many cases, there is d1 case, also d2 case, d3 case, d4 case, up to so on, up to d10 case. There is maximum minimum d1 case and maximum d2 case, also d0 case, and d0 case, d1 case, d2 case. There is many system, d1 system, d3 system, d2, d10, up to d10. In all these system, when electron are go to t to g or eg or dx square minus y square or dz square, what will be distortion? Agar how can you distort the system? how will be this complex will distort their d orbital. So let's see one by one here. This also for among them it will be different for low spin complexes. It will is different for high spin complexes. So let to check all of them. Is it clear? Okay, let to check for d0, d1, d2, d3 up to d10 system. That is let first of all that is d0 system. First d0 and d1 system. For d0 system what will be happen? D0 system will be like that. D0 system, this is, let's suppose, and these all are the 5 degenerate orbital integrals. If they are split in octahedral complex, what will happen? It will happen like that. It will be like that. That is x square minus y square, and that is z square, while this is xy, xz, yz. These orbital. So after that, when there is zero electron, there is no electron in either in T2g or eg. There is no electron, so there is no distortion occur. No distortion occur. Or you can say that, there are two complexes, there are two types. No distortion, distortion, distortion. Two cases will be arise. Sure. Here d0 system and d0 system there is no distortion, so we can say that here is no distortion. But in case of d1 system, but distortion will be occur in two cases. There may be t2g distortion, where maybe where maybe eg distortion. So for both we can calculate that how. Okay, okay, in d0 system there is no distortion occur, but in d1 system how will be the position? That is, it will be like that, x square minus y square, that will be z square, xy, xz, yz. So this is t2g, this is eg. So here is one electron. According to Horn rule, it will be felt like that. There is this complex may be slow spin complex or high spin complex. The electron will should be go into xy or yz or xz, any of the T2g orbital. So there will be only T2g distortion occur. T2g distortion occur. So T2g distortion occur will be in D1 system. That may be high spin or low spin. High spin or low spin. In both cases, this distortion will be occur in D1 system. While what will be position in D2 system? In D2 system, the position will be like that. Because here T2g distortions be occur because xy has one electron, while xz yz has nothing, no electron. So that's why these are asymmetric arrangement. Asymmetric electronic cloud. Due to asymmetric electronic cloud, the distortion will be occur. Some of its energy will be lower and some of its energy will be higher. So how is that? Which will be high and which orbital will have low energy? We will be discussed at after. But first of all, we should need to know that here is T2g distortion occur. Okay, but in case of D2 system, in D2 system both electron will be go into T2g, while Eg will be empty according to Horn rule. So here will also asymmetric distortion. When there is asymmetric distortion, which electron when there is asymmetric distortion in T2g, so T2g distortion will occur in D2 system. That may be high spin or low spin. Okay, while in D3 system, what will be happened? In D3 system, distortion will be like that. that is Eg, that is T2G. All the electron will be go into T2G according to Horn's rule. Um, no electron can be go to Eg and T3 system. Either the complex will be high spin or low spin. Electron should be go into T2G. So that's why here is symmetric arrangement, symmetric electronic cloud and symmetric electronic cloud. So all the orbital will have same energy, so there will be no distortion occur. So in D0 system, in D3 system, this may be high spin or low spin, no distortion will occur. So you can take screenshot from this position. So okay, let's D4 system. D4 system is the system when the system is high spin complex. High spin complex means it will follow the Horn's ruler when the system is high spin complex. So what will happen? Here is Eg orbital, here is T2G orbital, that is x y x z y z. So when there is x here and according to Horn rule, because this high spin complex, weak ligand are used. So one electron will go here, one electron will here, one electron will here. T2G are symmetric arrangement, while one electron will be go into Eg, that may be either go into z square or into dx square minus y square. Depend upon the electron, the distortion will be depend upon that the electron are in x square minus y square or in z square. So first of all, let's assume that it may be an Eg or it is in Eg, that can be in z square or y square, but you can assume that just it is in Eg. But you should know to you should need to know that Eg has a asymmetric arrangement. When Eg has asymmetric arrangement, so here Eg distortion will be occur. So in D4 system, when there is a high spin complex, when there is high spin complex, D4 system will be when D4 system in high spin complex, Eg distortion will be occur. So you can take screenshot from this position. Now I am just cleaning the board. Okay, so sorry, let's write here D4 system for low spin complex. For low spin complex, what will be the position? The position will be like that, that is Eg, that is T2G, that is T2G, that is Eg. And low spin complex, the uh, pairing of electron will be occur against Horn's rule. So because high spin, because of strong ligand are used, so the electronic first electron will unpair, all electron will go unpaired. After that, first the fourth one electron will be paired. So T2G again, it is asymmetric electronic cloud, so T2G distortion will be occur. So in case of D4 system, when they are low spin complex, T2G distortion will be occur. Is it right? Okay. For D5 system, what will happen? Let's suppose if this is a high spin complex, then what will happen? If this is high spin complex, let's suppose this is Eg. So in high spin complex, it will follow Horn's rule, because first of all unpairing occur. That is, let's suppose that is T2G, that is Eg. So first of all electron will go into T2G, after that it will go into Eg. So the 5 electrons are completed. So there is all are symmetrical, so there is no distortion. So we can write that D5 system, in case of high spin complex, no distortion will be occur. So guys, you can take screenshot. I'm just clearing the board, or you can rewind the video. So okay, thank you. Let's proceed. So let's start D5 system. D5 system for low spin complex. What will happen? It will be against electron. It will be against Horn's rule. That is Eg orbital. That is T2G orbital. T2G orbital. So what will happen here? That is T2G. First electron will go into singly paired. After that, pairing will occur because of low spin complex. So 5 electron are completely. So here T2G are symmetrically and low spin complex. So here is T2G distortion will occur. In case of D5 system, when they are low spin, T2G distortion occur. But in D6 system, let's suppose this is a high spin complex. What will happen? That is EG, that is T2G, T2G, EG. Here, what will happen? Let's suppose there is high spin complex, so it will be according to Hond rule. When according to Hond rule, first electron will singly paired. After that, the sixth one electron will be go into T2G according to Hond rule, pairing will occur. So here again, T2G are asymmetrically paired. Asymmetrically paired, so their electronic cloud is asymmetrically. So T2G distortion occur in case of D6 system when they are high spin complex. When they are high spin complex, but when D6 system are low spin complex, when they are low spin complex means when strong ligand are used, what will happen? There is T2G, that is EG. The one electron will be go here. The pairing will occur because it is against to Hond rule, because strong ligand are used. When strong ligand are used, it will be against Hond rule. When strong ligand are used, this the area, the delta naught, the crystal field splitting is much more. When crystal field splitting are much more, because the interaction of ligand with centimeter atom is very large, is very effective interaction, is very huge interaction. So their splitting will be high when the strong ligand are used. So when the splitting is high, that's why electron will not be go into the EG orbital, but will pairing occur first time because the delta naught is increased. So that's why in low spin complexes, the pairing will occur against Hond rule. So here in D6, when they are low spin complexes, T2G are symmetrically paired while EG are empty. So that's why here is no distortion. In D6, when they are low spin complexes, no distortion will be occur. In D7 system, let's suppose D7 system, when they are high spin complex, what will happen? That is T2G, that is EG. It is when they are high spin complex, first electron will go here, second electron will go here, third electron, fourth electron, fifth electron, sixth electron, seventh electron. So it will be according to Hond rule, because weak ligand are used here. So due to the high spin complex, so T2G are asymmetrically paired while EG is symmetrical, so T2G will be distorted. So in D7 system, when they are high spin complex, T2G distortion will be occur. But when D7 are in low spin complex, what will happen? D7 are in low spin complex, that is EG, that is T2G. So when first electron, second electron, it is against Hond rule. So EG will be asymmetrically paired of 7 electron. So here is EG distortion occur in D7 system when they are low spin complex. When used as a low spin complex, when low spin complex are mean high, when strong ligand are used in D7 system, when there is 7 electron in D system. When there is 7 electron in D system, so low spin, so the pairing will be occur. That's why EG orbital will get 1 electron. So that's why EG has asymmetrically paired. That's why EG orbital have distortion. Distortion will be occur in EG orbital. So let's have a D8 system. D8 system may be high spin or low spin. In both cases, they are equally. How? That is, let's suppose it is dx or dx or y square dz square, that is T2G, that is EG. Here it is according to Hond rule. When high spin 1 2 3 4 5 6 7 8, when this according to Hond rule are against Hond rule, first electron, second electron, third electron, fourth, fifth, sixth, seventh, eighth. So in both cases they will be same. So but in both cases in T2G, AG both are symmetrically paired, so no distortion will occur. In D8 system, they may be high spin or low spin. In both cases, they are no distortion will be occur. So in D9 system when they are high spin or low spin, in both cases they are same. What will be happened? This is EG, this is T2G. So let's suppose according to it is a Horn rule, when they are high spin complexes are used, when low spin complexes are used, according like Horn rule. 1 2 3 4 5 6 7 8 9. So here EG orbital is a symmetrically, EG set is asymmetric pair, so here is EG distortion will occur. So we can say that in D9 system they may be high spin or low spin, the D9 EG splitting will be caused. But in case of D10 system, that is maybe high spin or low spin, in both cases they will be equal. That is T2G, that is EG. So what will happen here? Here is when according to Horn's rule, all electron will go into all the orbitals. So all the orbitals are symmetrically paired. T2G set and EG set, both sets are symmetrically paired. So there is no distortion occur. So in case of D10 system, there is no distortion occur. So these all are the system. So you can see that clearly that no distortion in T0 system, T3 system, that may be high spin or low spin, no problem. But in D5 system when they are high spin, when D6 system when they are low spin, when D8 system when they are high spin or low spin, when D10 system when they are high spin or low spin, in these cases will be no distortion occur because all are symmetrically paired. But in D1 system when D1 system and D2 system and D4 system when they are low spin, D5 system when they are low spin, D6 system when they are high spin, D7 system when they are high spin, in all cases T2G set will be asymmetrically paired. So when they are asymmetrically paired, their orbital will have asymmetrical electronic cloud. So there is a little bit distortion occur. That's why here this distortion is called T2G distortion. But in case of D4 system, when D4 is high spin complexes, when D7 system is low spin complex, while D9 is high spin or low spin, in both cases there is here only three cases where EG set have asymmetrical pairing, where EG will have asymmetrically paired, so their electronic cloud will be asymmetric. That's why it will be distorted, so it will call EG distortion. So EG distortion will be present in only three cases or four cases, and only in four cases. If it is D4 for high spin complex, D7 is a low spin complex, D9 is high spin complex, and D10 is a low spin complex. In only these three cases EG distortion will be present. Is it clear? You can take screenshot. Let to proceed forward. So let's proceed. So in these of cases where no distortion occur, here is no distortion occur, but here distortion occur. But there is two cases. One is T2G, one is EG. So there is two cases. In T2G sets, we know that the T2G set orbital is in between axes, in between axes, while EG orbital are lying on the axis, so EG orbital, because EG orbital, that's why EG orbital have more interaction with ligands, more interaction with ligands, while T2G set has a very less interaction with ligands. So that's why the T2G distortion, T2G distortion is very less. Let to take the T2G distortion is a very very less distortion, that distortion can be negligible because it is very less distortion. But EG set, it is greater distortion, it is greater heavy distortion, because they have high interaction, because their energy is they have very high interaction with ligands, because they are lying on the x, while T2G has very less interaction with ligand. That's why its distortion will be very less. So we can neglect T2G distortion, but EG distortion cannot be neglected. EG distortion is heavy distortion. So let's start to proceed EG distortion, that how in EG cases how distortion will occur. So let's start. What will happen later? There is only, as you can see here, as you can see here, there here is only D4 system. D4 system is high spin, D7 system is low spin, and D9 system. Here only in these three cases EG distortion occur. So let's here, when D4 system are used, how will be distortion? This is x-axis, that is x square minus y square, that is z square, that is xy, xz, yz. When D4 is a high spin complex, high spin complex are used. So the electron will be, yeah, right, when high spin complex are used means weak ligand are used. So it will be according to, it will obey Home rule. So one electron will be go into here, one electron will go into into EG sets. But now let two cases are generated. One case, that electron maybe go into z square, maybe go into x square minus y square, can be go into x square minus y square, can be go into z square. When they go into x square minus y square, then how can be distortion occur? When they go into z square, how can be distortion occur? So there are two different cases. We can say that when electrons go into x square minus y square, then what will happen? Let's discuss this case. Let's discuss this case. So in this case, the energy of, let to clear the board correctly, you can take screenshot. What will be happen? So if electron is present in, if electron is in x square y minus y square, then what will be the situation? So here the situation will become the x square minus y square energy decreased, the energy of x square minus y square decreased, while the energy of z square increased. Why the energy of x square minus y square increased? Because the energy of x square minus y square decreased because it has electron. So so this orbital shows repulsion to the ligands, the ligands that are coming in the way in of x square minus y square. The ligand are, the ligand cannot be approached easily to the system. That's because electronic repulsion occur. So that's why their energy will be decreased, while the z square orbital that have empty orbital, so in a ligand can be effectively approached, can be very easily approached to the system, to the central middle atom through z square. That's why their energy will be increased. But here in T2G sets, the xy orbital are in between x square minus y square, so their energy will also decrease, because x square minus y square has a very low energy. But xz and yz each contain one z and one x and one y from x square minus y. So this energy will be same, but the z square is greater energy, so this energy is also greater as compared to xy. So that is xz and yz. So the configuration will be like that. This will be distortion occur. It's mean that it's mean that there is a four cases. There is, let's suppose there is centimeter atom. So here that is ligand are in between axis. These ligands are along xy plane, so they are in this situation the ligand cannot approach to the central metal atom because electron exchange is present. So the distance of ligand will very large, very away from the central metal atom. But in case of z square orbital, the ligand will be very the ligand approach to this metal nearer. That's why the bond of the axial bond will be shorter while the equatorial bond will be larger. So that's why here geometry will be occur. That geometry will call the complex will be formed. The complex will be formed compressed tetragonal geometry, or you can say in short axial bond, what will we call it is called oblate geometry. Short axial is called oblate geometry. Is it clear? Yeah, this will be happen. But when case of d4 system, when the electron, these are the system when electron are in dx square minus y square. But if when electron are present in let's take the correct position of this board. So let's start. When that is d4 system, also high spin, but the electron are in z square, dz square, then what will happen? Then it will be like that. That is x square minus y square, that is z square, and that is this is xy xz yz. So according to Horn's rule, one electron will be go into each section. So the when the electron in dx square minus y square, the situation will be like that. When the electron go into z square, what will happen? When electron go into z square, what will happen? The energy of the distortion will be like that. The energy of the energy of z square will be decreased while the energy of x square minus y square increase similarly in the above case. The reason is same to same because it is because the energy because z square has one electron, so the ligand that are approaching in the way of z square to the central metal atom, the ligand cannot approach to the central metal atom correctly because the electron in d z orbital will show resistance to the ligand and show repulsion to the ligand. That's why ligand cannot approach. That's why the axial bond of the system or the z bond of the system, the ligand that are bonded with z are larger bond, while the bonded while the bond while the x or minus y square energy is increased because it has no electron. So that's why ligand are effectively approach to the system. That's why its energy is increased. That's orbital energy increased. When x y minus y square energy is increased, that's why xy energy will also be increased because xy is in between x square minus y square, while xz and yz will be lowered. Xz and yz will be lowered, and the electronic configuration will be like that. So here z square is longer. Here orbital can be effectively approached to the central metal atom from this position, from the equatorial position, while axial position orbital ligand cannot be in equatorial position. Ligand effectively approach to the system while to the central metal atom, while axial from axial position the ligand cannot approach effectively to the system because electronic. That's why the axial bonded will be larger and the equatorial bond will be shorter, and the system will be called, the geometry will be called elongated tetragonal geometry, while it is also called while it is also called prolate geometry. Prolate geometry. Is it right? Same to same cases are present in D7 system, D9 system. Let's suppose in D7 system what will happen? D7 system when it are low spin, one electron will be go here, one electron will be go here, one electron. So pairing will occur. After that, D7 the electron will be go into Z square. If they are in Z square, then this situation will be like that. If they are go in when they are D7 system, if they are when they are D7 system, when the electron are go in X square minus Y square, then situation will be like that, and the configuration will become like that. So here will also be configuration become like that. D7 system, the configuration will be like that. But when D9 system, in D9 system, one electron, there is 8 electron and one electron. If the second one electron in each set will go into Z square, then repel, then position will be like that. When the second electron will go into X square minus Y square, then the position will be like that. Is it clear? Okay. These all are tetra Jahn Taylor distortion, and very easy. Thank you so much. If you have any confusion, if you have any question, then you can ask me in comment section, or also you can ask me in my WhatsApp. My WhatsApp number is also on the YouTube thumbnail. First, when you are searching my video, on my video, my WhatsApp number will be given. You can also contact me. Also, you can contact me. My WhatsApp number is also in description, and my Gmail is also in description. So you can contact me here if you have any problem, if you have any question. So please subscribe my channel. Thank you very much. It make me happy, feel happy that my students are supporting me. So please subscribe my channel. Thank you very much. Best of luck. Goodbye. Best wishes.